Today is the 18th. Oh, it is. Thank you. Gee, I wonder if I've been screwing that up all day. Okay, so hybrid vigor. The offspring, a hybrid offspring, can often be bigger, stronger, faster than either of its parent species. So where do we see these hybrids? Typically, it's when we create them, and occasionally accidentally. So mules are one of the most common ones that we talk about. They're a domestic hybrid, horse strength, maybe a little bit more, or donkey strength, horse size, and actually even a little bit bigger. Ligers. Well, it is the offspring of a lion and a tiger. They don't happen in the wild. They sometimes happen. There are what are called open zoos, where you have multiple species sort of interacting on their own terms, and they are compatible. They have enough similar DNA that they can reproduce and have an offspring. They're not fertile, but it does happen. I worked, and I think I've mentioned this before, I worked for the Division of Wildlife right out of college in the fisheries section. I was a fish squeezer. I went out and I got paid $8 an hour to squeeze walleye for eggs and sperm. My friends had a lot of fun making jokes at my expense that year. Because you dress up head to toe in rain gear and rubber boots, and you wear big like felt gloves so the fish don't slip out of your hands, and you pull up a giant net and you hook it on the edge of the boat and you fish out the walleye, and you stick their nose in your armpit and you hold their tail in your hand and you squeeze their belly until all the eggs shoot out into a bucket. And you do about 10 females that way, so you get a nice crop of eggs in the bucket, and then you get one male, and they're littler. Stick his nose in your armpit, hold his tail, tickle his belly, he sperms in the bucket, put the cap on it, and it goes off to the hatchery. And then you stock them. That's how we have the kind of walleye populations in Ohio lakes that we do. It is not natural reproduction because Division of Wildlife is paid for with hunting and fishing licenses, and people like fishing walleye, so the division puts a lot of money into breeding walleye, so we have more walleye. It's a fisheries management thing. Now, walleye are delicious. You ever eaten walleye? I love walleye. Ooh, big fried walleye sandwich and coleslaw. Love it. Saugers are another game fish. They're not real common. Anybody here seen a sauger live and up close? They're a smaller game fish, but I believe the appeal of saugers is that they're a real good fighter, and a lot of sport anglers like a fish with good fight. And so the goal was, well, hey, let's make something that's as tasty and delicious as a walleye and has the size of a walleye, or maybe even a little bit bigger than a walleye, but has the fight and the instincts of a sauger. And the saugeye was born. So it is one of the hybrids that are created by the Division of Wildlife. I'll tell you about the muskie hybrids a little later, and they seem to have improved that program, but starting out that was pretty rough. So that's where we typically see non-fertile hybrids. Why don't they happen in the wild? Why don't sauger swim up to walleye and say, hey, you want to lay some eggs here? Because they're not their species, so what? Maybe they have a preference for some other species. Maybe they think that other species is very attractive. Why don't they mate? Why don't saugers and walleye hook up? What could be preventing that? Instinct? Okay. What?
No.
Oh, if you got an answer, come on. Share.
Appetite.
Appetite? In some cases, you have, and you're getting to one of them. In some cases, so like, why don't coyotes and rabbits breed? Because coyotes don't breed with rabbits, they eat them. Coyote, a rabbit walks up to a coyote and says, hey, do you want to make some rabbits? And the coyote says, chomp. We don't even consider it. They're not closely related species. But in the case of saugers and walleyes, they're closely related enough that they can have babies. Why don't they? Because we do not typically see hybrids in the wild. There are a few exceptions, and we're going to talk about some of those exceptions, because some of them are pretty interesting, and some of them you guys have some personal contact with. So, I heard the word. Hybrids don't usually occur because species have isolation mechanisms. So species are generally, what does it mean if you're isolated? By yourself. Poor Daniel is isolated at his island. His island mate is on field trip. You like it? Okay. But in wild species, they're generally isolated from other species, and that's why you don't see cross-species reproduction. Now, isolation is also how we end up with new species. In the image that you've got there, you have a bunch of bird species that all have a common ancestor. They're geographically isolated. Oh, I gave it away. They're isolated one from another because they're living on different islands. They can't get to one another. That's one way to be isolated. So sauger and walleye. Do you think it's just that they're not in the same lakes? They live in some of the same lakes. Why don't they mate? Why don't sauger go fertilize walleye eggs? Why don't walleye males go look for sauger females and fertilize their eggs? What's preventing that? Because it doesn't happen in the wild, so something has to be preventing it. Anytime we find something that always happens or never happens, we kind of want to know why. Because if it's random chance, something, yeah, sometimes not. But if it really generally never happens or really generally happens all the time, there's usually some underlying reason. But some kind of isolation. Okay, before we even answer the question about the sauger and walleye hybrids, if we think about the clipbirds, what happened on their little island? We had this mountain range sort of erupt. The birds in the west can't reproduce with the birds in the east and vice versa. They go from being one population to being two populations. They're isolated. Each population starts to change. What happens after 500 generations? It's possible that they're so different that they're no longer even the same species. If the conditions aren't all that dissimilar, they may just be isolated populations. But it is very possible that in a case like that, they change so much that 500 years or 500 generations down the road, you can tell they had a common ancestor, but it's real clear that they're not the same species anymore. So wait, what's keeping the eastern and western clipbirds from breeding with one another? Isolation, but specifically what? The mountain. They are physically separated. If any of you have siblings, have you ever been physically separated from your sibling for fighting? Like, okay, you go sit over there, you go sit over there, no looking, no touching, no talking. Okay, you're physically separated, you can't get to one another. It's a geographic issue. So if we look at our types of isolation, there are in fact two types of isolation, and the first one is just what we saw with the clipbirds. It's geographic. Those two populations can't breed because they can't actually reach one another. They literally, physically cannot interact. That is geographic isolation. What kind of isolation did the clipbirds experience? Geographic isolation. There was a physical barrier. You could put it on a map. You could show on a map. That's how you think about that as geographic. You show on a map why they couldn't breed. Big mountain in the middle. That picture at the top is two different species of squirrel, both from Arizona, and they are separated by, I don't know, probably 100,000 years in a big ditch, a 7-mile wide ditch, a little thing called the Grand Canyon. And they're clearly related. I lived out in Arizona for a while. I took a little time off college and went and lived out west on a mountain in southern Arizona. And on the southern side of the Grand Canyon, and in southern Arizona in general, you only see these squirrels. It's called the Abert's squirrel. And they're cute because they have little tufted ears. They look like gremlins or something. They're not like the squirrels we have here. And they're about the size of a fox squirrel, but their coloration's different. They have the tufted ears. They have a few other features. If you go on the north rim of the Grand Canyon and north, you only see these squirrels, and these are the Kaibab squirrels. They clearly have a common ancestor. They're very, very similar. They are, however, different enough that we do call them two separate species. That's geographic isolation. There is no bridge across the Grand Canyon. Squirrels are not known to be great backpackers. They don't hike down to the bottom of the canyon and hike back up the other side. Why would they? Conditions are pretty harsh down there. So they're geographically isolated. They can't reproduce. Now, if we have sauger and walleye living in a lake together, are they geographically isolated? Mm-mm. Nope, they're swimming in the same water. There are no little fences. There are no divisions that say this part of the lake, walleye only. The other kind of isolation is what we call reproductive isolation. And this means that there is some biological roadblock to reproduction. I remember a college prof I had talking about this concept, and he said, there are bird species in which what one species considers a mating, a courtship behavior, the other species looks at and thinks of it as the kind of behavior that their prey exhibits. So you show up and do your cool little courtship dance to attract a female, and she promptly kills you. That's a roadblock to reproduction. There are not going to be any offspring there. It's a behavioral issue. There are timing issues, too. So these are two frog species, the wood frog and the leopard frog. That's the wood frog. That's the leopard frog. We have both of these frogs out in our woods. Has anybody seen one of them? Leopard frogs, the spotted ones, are not all that uncommon. They're more commonly seen. I look for frogs, and I spend a lot of time in woods and creeks and stuff, and I have only seen, I think I've seen 2 wood frogs in my life in the wild. They're real secretive, and they're well camouflaged, and you just don't see them very often. These two species are related. Wood frogs start breeding really early in March. Leopard frogs start breeding later. Peak of breeding for wood frogs is significantly earlier than for leopard frogs. So it's a timing issue. Now, do you guys understand how frog reproduction works? Okay. Female frogs lay eggs, male frogs come along, and they squirt sperm on top of the eggs. That's what happens. And the female frogs get to be picky, and the male frogs have to be impressive. So the male frogs all line up. They sing their little hearts out for love. You heard frogs singing love songs on a summer spring evening. Dong, 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 dong. Yum, 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 yum.
Orchestral.
So those were in order: green frogs, bullfrogs, and spring peepers. 3 different species of frog. There are points in the year when you can hear all 3 of them calling, but usually the spring peepers start first. And the spring peepers are a tiny little frog. They're a golden, glistening little teeny little frog. You'll find them in puddles and ditches and woods and all kinds of edges of lakes and stuff. And they're tiny and they have pretty little singing voices. And the girls say nothing. What did the female spring peeper say? Nothing. The boys sing their hearts out. Now, that little spring peeper song, bullfrogs just don't find it attractive. A female bullfrog has no interest in a male peeper's song. And male peepers are living in the shallowest of water. Bullfrogs need a little bit deeper water, so that's sort of a geographic feature. But the big thing is they start their breeding at different times. Bullfrog breeding doesn't kick in until nearly May, and most of the peepers are done breeding by early April. They're never going to meet up. By the time the green frogs start breeding, by the time those males start producing sperm, because these are not animals that can breed any day they want. They become fertile once a year. Those females produce eggs one time per year. And when they produce eggs, it's now. So when they're finished producing eggs, they're on to the rest of their lives. If your species aren't fertile at the same time, you're not going to reproduce. So saugers and walleye, why don't they reproduce?
Because they don't.
Go ahead.
Because they're breeding season 8.
Okay, timing. It's all down to timing. When I worked for Division of Wildlife squeezing walleye for eggs and sperm, oh God, it was awful. It was March. You know how cold it is in March, often, late March? Basically, the walleye, they would always say the walleye run would start when you could get a boat onto Mosquito, when there was enough ice off that you could get boats out. And so, like, third week of March, rain gear head to toe, rubber boots, and big felt gloves, and bone-achingly cold because you're in the water all day long. And it goes for about 3 weeks. And while the walleye are spawning, if you are working on a walleye spawning project, you are working 7 days a week. Because once they're done spawning, there are no more walleye eggs for the year. So you get them while you can. And you get as many walleye eggs off to the hatchery during that little window that you can. Because then it's done. It's over. So they start in like mid to late March. They're done by the first week of April. And the sauger don't start spawning till mid-April. And there will still be some sauger spawning in like late May, early June. They have a much longer reproductive window. In the wild, those two species are never going to produce babies. It's not going to happen because their timing is off. Okay. After we have just about so much isolation, any kind, and we have some kind of disruptive selection or directional selection working on variation in the species, we can get multiple species. We call the process of making multiple species speciation. I should just say a new species. So speciation is the process of making a new species or making multiple species. But it takes isolation. They have to somehow not be reproducing together anymore. So those populations have to get split. Like in the clipbirds, we had geographic isolation. In the clipbirds, did we actually have disruptive selection or did we have directional selection? Which was it? Who were my, oh my gosh, I'm going to die people? I seem to recall you saying that. So was that directional selection or disruptive? Were both ends favored and the middle cut out? Or was natural selection pushing your whole population in one direction? You had a little beak, right? And you had all marbles. Yeah, you're not making it. So you were at one end of the extremes, and you were going to die, and the mediums were probably going to die. The only ones left over there were going to be large. On the other side, it was all popcorn. If you had a big bill, you couldn't get enough food probably to get enough calories to survive. It was getting pushed in the other direction. That's directional selection. So we had, starting, we had this sort of even distribution, and after some amount of selection occurred, we had a distribution like that, and we had a distribution like that. We had directional selection in two different directions. After 1,000 generations, we might very well have two different species of clipbirds. And they might not have a whole lot of variation because one particular version of a trait was favored. So we have those two schools of thought: gradualism, lots of tiny incremental baby step changes over time; punctuated equilibrium, no change, no change, no change, boom, big change. What evolutionary biologists will say is that both of these probably happen. You know, it used to be a debate, which one is it? Well, it's probably both of them, depending on the situation, depending on the species. They both have kind of been observed, but they're just two different sort of mechanisms. So we're going to talk a little bit about a couple of hybrids that you might have seen in Ohio.